introduction. As always, pleasure to be here, and this time it's back-to-back presentations. First, before I start, I'd like to pay my deepest respect to those who lost their lives during this hard season, especially the hard time they are undergoing at this moment, suffering of their families as well as communities around them. So that brings to me to the topic what I'm going to discuss with today, where we need to invest our effort into safety and resilience of our community. That's what I'm going to share with you next 20 to 25 minutes. My experience, something I'm doing at the moment in UNSW and Australia. So I will share some of these projects as well as the work we are doing within Australia in this space. Slightly different to traditional civil structural engineering, which we discussed in tall building session, but I see this as the future of a country. If you invest money on this, there will be benefit to any given country, whether it's a developing country or developed country, it doesn't matter. So let's see what I have to offer in this field. So I'll start like this. Definitely, if you invest money on defense or defense technology, which we can see in many developed countries, it's an investment for both defense and civilian. Why I'm saying this? I have an example in next slide. We call it spin-off technologies because what we develop in defense later will be transferred into civilian space gradually. There are many good examples for that. You can see the internet what we are using today. Started with US defense, if you know about the history, and later transferred to help the world, and we are using it. GPS, without GPS I don't think we can find routes now, especially in Australian type of country which is very large. So GPS system. But I like to highlight very simple thing. Duct tape. Are you familiar with duct tape? Most of us. Doing plumbing, we use duct tape at household. Even duct tape is a product from World War II where they want to seal ammunition boxes. So they were searching for something suitable for that sealing process of an ammunition box. So then they developed this through World War II, money invested on defense, but now without duct tape, can't survive. Plumbers, electricians, those other trades, they all use this plumbing duct tapes in theirs. In Australian context, we have something called satellite-based IoT system, which is a small data pocket system that we use small satellite system to transfer data from. So again, developed through defense research and applied into civilian space. You can see those investments, especially in US and other developed countries, are invested on defense space initially, but gradually it has transferred into civilian space. That's what is important us to understand. If you are thinking about developing this country, now last few weeks I heard like a lot of stories about redevelopment. We thought about this when tsunami came. We thought about this some other events, 2016 flood. And if we really want to develop this, we need to, I think, have a change in our attitude, change in our direction. We need to invest money in right directions, especially thinking about innovation and technologies. Because as a country, we have the brain power. What we are lacking at this moment is investing money in the right place at the right time. So if you think about current situation of what we are facing right now in Sri Lanka, we have severe flood issue. We have some concerns about the damaged structures. We have problems with the landslides, all these natural disasters. If you go to this website, you will find information from USAS, that is US Army Corps engineers. They actively manage 700 dams and levees. They design dams and they manage flood mitigation systems. They help with the disaster management. So, what I'm going to highlight from these things, these technologies develop in defense fields, and the knowledge they develop through different other activities, they can transfer into disaster management like what we are facing today. Now, our main struggle is to sometimes find these resources when it's needed. So, if you think about this, we need new technologies, we need new innovations. That is the theme of this conference, as well as we need people to help us when it's needed. So if you read through this paragraph, USAs have currently controlled 700 plus dams in USA, including Mississippi River flood control. So that's a good example of what I was talking in previous slide. How important protective structure or defense research into other areas of our life. Now, when I come into Australian context, I have listed all our national priorities at this moment. Among them, one of the most important one is building secure Australia or resilient Australia as a nation. So, if you see most of the other developed countries, they put this as a priority and they invest significant money on this space. And the technologies are developing through that process later benefit, directly or indirectly benefit other industries. This is the beauty of this book. Now, with that, next phase of my presentation, I like to highlight some of the innovations what we are doing in protective structure engineering. It's a subset of that what I discussed before, defense or defense-related research. So I'm taking you through some of the innovative work we are doing in Australia in protective structure space. Why it's required, I will highlight in next few minutes. When it's come to developing a resilient nation or safe nation, we need to think about protection or safety side of our structures. It's a must. When we develop Sydney Metro railway system, this is one of the leading ones in Australia as well. Driverless trains travel every 4 minutes within Sydney suburbs. One of the projects I got involved as well. This is a central station, diagram is taken from central station, multi-story building, and you can see some of the key features of that. But what I want to highlight is, there's an explosive device, someone placed somewhere, should we consider that in our design? Are we considering these things when we are thinking about infrastructure? These threats are there, both natural as well as man-made threats. We saw already natural disasters, we faced them already, we know about man-made threats as well, and those things should be considered when we think about developing our infrastructure in future. We want to become safer and resilient nation, that's what is important. We need to consider this aspect. So, simple metro station like this, underserved, I can't disclose that amount, but they have designed their structure to withstand possible threat and the blast is only one component. There can be other things like vehicle collision. These tourists are using that as an option now. Many other natural disasters against flood or earthquakes and other things. So we need to consider them seriously in our designs. The reason is, when there's an incident, we need to protect our people. If you remember the previous diagram, underneath that concourse area, there's a railway track like this. There's an incident in that particular level. Explosion should not disturb the functions of the operation of this railway track. That's the concept they adopt in most of the design. The message we can take from that to us is, if you are designing or if you are engaging in infrastructure development, we need to think about these aspects in future. That's how we develop our resilient or safer environment for our people. So I'm gradually going a bit deeper and focusing on more blast side of work, highlight the importance of these things in future work, even in Sri Lanka. So I'm asking a simple question from you. Is it possible to engineer a structure under any given explosion with zero damage? Answer is very simple, it's no. If you try to do that, your structure will look like something similar. Pretty simple. This is a mistake many engineers are having at this moment. So they try to protect the structure to complete zero damage. It's not possible. So what we need to understand is, we need to develop within us, we need to develop the knowledge to identify critical component of a structure, how they behave under this extreme loading, and treat them individually when we are doing this. So this knowledge is lacking in many parts of the world. That's what I want to bring you up to this point. So that's what we are doing as research in most. Protecting people means that we identify the critical component of a structure. It can be defense, it can be civilian space. We need to understand how these structures behave, both material-wise and structures. I'll give a good example for that. I think most of us are familiar with wind loading. So, if you take 100 kilogram of TNT, at 25 meters distance, there's an explosion. At 25 meters distance, you will get roughly 90 kPa pressure. If you are familiar with wind loading, tall to medium rise building, even at ultimate limit state, you will get roughly 2.5 to 2.5 kPa pressure. So you can see magnitude-wise, blast load at that distance, far field distance, is 40 to 50 times more. Closer you get the explosive device, the threat is more. Can be 1,000 times than normal wind is. But there's a big difference as well. Wind is, we consider as relatively slow moving, and blast relatively dynamic when you compare. Last event, it's happened within few milliseconds, where wind is few seconds. So this dynamic difference is there, but the message I wanted to highlight, what we adopted in our simple design practice for wind and other loads are not working with blast or blast type of loads. That's why we need to keep an eye on this area and develop knowledge within our engineering community and make sure they understand the importance of these things. Bring that knowledge from defense space into our normal. This is what we do regularly in our We like to do these things, enjoy the sound, that's why I kept the soundtrack as well. So the top one is hydrogen explosion. I will explain that one as an example. Second one is the National Blast Facility, which I'm leading currently. The capability of so what I'm highlighting here is when we are thinking about the structural design for these natural disasters or extreme loading, we need to have thorough understanding how these structures behave under those extreme load. If you are aware of this only, you can tackle these problems. So I'll bring this now to those two examples I like to highlight to show the innovations and capabilities those developed countries are taking in this space at the moment. By giving them, we can understand where we should move as a nation and develop our capabilities for our future. The first one I'd like to highlight is the facility I'm building up at the moment. I'm leading this one. It's a $2 million worth, Australian dollars 2 million worth funding to build National Advanced Blast Simulator for Australia. What it means? When it's come to blast testing, we can't go every day to the field and test these things. We need to go far distance from city areas to do this. It's extremely difficult and painful exercise if you are not enjoying. So what we need is something that we can handle day-to-day basis in a laboratory environment. So the development of advanced blast simulator is meant to do that purpose. It's an Australian Research Council grant project. Initially came to University of Wollongong and then transferred to us recently to take control and manage this facility. Only one such facility in Southern Hemisphere. There are few in USA, larger in scale as well as usual. But we value this one because having such an instrument in a laboratory environment, there are many challenges. I'll explain briefly how it works so that you can actually understand. It consists of three components. Driver section, where the gas explosion happens. Actually, this instrument operates through gas explosion. It occurs here, driver. Propagate through the tunnel section, and we have our structural element closer to the dump tank so that we can test them regular basis. Similar to wind tunnel, if you are familiar with wind tunnel, but more stronger than wind tunnel because pressures are developed in higher magnitude than a wind tunnel. So I'd like to take you again back to that, if it's well. So the setup has been created as a module formation. You can easily transport and re-establish. The tunnel part is made out of 4 parts. And you generally fix steel, concrete samples to test, and pressure wave generated in the driver will propagate through the tunnel. When it's reached that location of the testing sample, it's almost become planar wave. Planar wave means flat wave, so that it will do the purpose for us. Apply that load throughout the system. That's the beauty of this setup. Initially designed in USA and transported to Australia for the establishment. I will show you 2 videos with the real life time. So this is the sample. Generally, it's normally inside this part. So all my team working here at this moment. You can see the distance between them and us and the instrument is few meters. Can you do this one in real blast trials? No. But this setup, the advantage is we are working within few meters with all the safety approvals, and we can handle the instrument nicely within that distance. And there are many state-of-the-art equipment working here. It's not one thing, this is a big instrument, but what is happening is the most interesting part. One goes into our academic research, data loggers, high-speed cameras, all other sophisticated equipment here. So we can test. The interesting part of this instrument is it can test especially traumatic brain injuries, TBIs we generally call it, because this is the main problem for our defense people or even civilians in a blast situation. So we can easily put dummy models and test them. There's a clear interest on that part. Steel plates, it's like bread and butter for this instrument every day. Concrete samples, that's usual. And many other things like we can even build, if you are familiar with like a city model of Vitana, we can do something similar to observe how a shockwave profile propagates through a dense city environment. These are the beauty of this instrument. This is these capabilities are not there or easy to achieve in field trials. It's costly as well as time taking. And in addition to that, we are doing state-of-the-art blast testing, field trials as well. This is one of the examples where we tested concrete slabs, which commonly used in Australian buildings, especially medium-rise buildings, low-level floors. We want to have a shallow beam plus relatively small thickness slab to maintain that clearance. So we want to observe the capability of those slab systems, regularly used slab systems, under possible closing detonation. That's what we did. We went with C4 charges. If you're familiar with, there are many chemical explosives they use in the business. C4, TNT, and some others. Commonly used ones those are the ones. So we put up to 10 kilogram C4 here, and we created the explosion and reported them in academic level in our population. So this is what I'm saying. This is the level that required if we are to become resilient country against these extreme threats. Threats can be both natural as well as man-made. Before I finish, I like to highlight this new area we are taking. It's not a new area for us, but there's a clear interest in the community on finding alternative food. We all know most of the researchers are working, but my interest is not in making hydrogen or green hydrogen. But my effort is to protect people against possible explosions that can generate through adopting hydrogen as food in future. Why? If you think about hydrogen, it has low ignition energy, flammability limit is low, and rapid reaction ability. There are many other characteristics that benefit hydrogen to go into ignition very quickly, and low density as well. So it's very dangerous or flammable material. There are many incidents reported all over the world with hydrogen gas leaks, and this is one part of this hydrogen industry that we expect in few years. So our infrastructure should be ready by that time when the hydrogen is introduced. Our infrastructure, our engineers should be ready to understand this threat so that we are ready to actually mitigate possible threats in the future. So this is a very innovative area. US, they are funding billions into this sector. Australia, again, same. So we need to understand the threats that can come. Just to summarize, I won't go into very technical details today because it's a keynote. But I want to highlight, hydrogen can create those explosions in three ways. What we call deflagration, mainly the fire dominate this phase? Fire is the dominant force over there. Third one is the detonation generally. Detonation, so I think there's a spelling mistake there. It should be detonation, not deflagration. Third one, we have the shock wave, it's read that shock wave velocity. Detonation is very similar to normal explosion. In between that, we have something called fast detonation. I know that you won't get the message right now, but next time we'll give you some sort of understanding. These are the captures we got recently. The video here gives you deflagration, where the fire dominates the explosion. This is a real hydrogen balloon without any restraint, explosion under ignition through small charge. It can be a cigarette butt, can be anything else, so it can ignite hydrogen very quickly within a fuel station environment. That's what we are interested in. It's again Australian Research Council funded project. You can see how well we capture this phenomena, and there's a theoretical background behind this. I won't go into that today. This one is almost like fast deflagration. It's mixed with deflagration and detonations. But next one is the most interesting one. This is like a real blast scenario. This thing is captured through state-of-the-art high-speed cameras at very high frame rate. So that's why you can see these visuals. So you can see, if you carefully see this one, you can see even shock wave is moving through air gradually. So what is the message to take away from these discussions? There are many areas of national priorities for civil and structural engineers beyond traditional research. This is my message continuously to you. Even when I met students from Morocco a few days ago, I passed the same message. We need to think about beyond that traditional research. We are to succeed in and develop this nation as a resilient and safer nation. That's the message to take away from my lecture today. With that purpose, we are thinking about establishing International Association of Protective Structure, Sri Lankan chapter, which is attached to the international body within next few days. I think we have initial interest and there's a clear interest from the community. And the aim of this is to generate some interest and awareness of these areas that are required to the development of this nation. If you are interested, I think definitely be in touch with either Professor Ranjit, Professor Priyan, or myself. We will guiding you into the setting up of this one. It's made for, at the moment, the international body has over 650 members and 4 different member categories. And the most important part is membership is free. So you can, if you want, you can join and get those information from them and see the world in a different angle, which I believe we are still lacking in terms of the knowledge of the country. So the main purpose of establishing this, we have already created the logo, and I think we have already started some discussions. And most likely we will have these sessions continuously attached to the Kandy conference with the permission of the co-chairs within next few years or even beyond this point. And it will be useful for our students to participate for this knowledge, and we will bring international community into this, in this space, and give them knowledge how to tackle problems like this if that occurs in Sri Lanka. This is a Beirut, Lebanon incident where the ammonium nitrate storage exploded with high temperature or man-made ignition. I'm not going to discuss the cause of that, but you can see the devastation caused by that, and we need to be careful on this. It's a natural effect, I would say, but both man-made and natural disasters are a threat for any nation, whether you are in a developed country or developing country, it doesn't matter. So with that, I will conclude my talk today. I hope you got some insight into a different area of research or different area of the industry, and happy to answer any question during our panel session with Leora.